All right, part 3. So you're finding a bunch of derivatives. So part 3 meaning page 3. So this guy I can tell you just by looking at it, this is a chain rule. And this will be my outside, this will be my inside. And when I use my chain rule, let's do that in, we'll do 3 colors. So f prime of x equals, derivative of the outside would be the secant, the tangent. Leaving the inside exactly the same as it was, I'll do that in blue. That was the original color I used. And then multiply by the derivative of the inside, which would just be the 3. Now, you can't forget that there was more to the problem. There's this 4x, so what's the derivative of 4x? It's just 4. Simplify the problem, and I get that the 3 could come up front, but the rest of it pretty much will look the same. And then plus 4 at the end. Letter B, I'm going to do a quotient rule. The derivative of the high is 3, the derivative of the low is 4. And so let's say the quotient rule, low, d of high, minus high, d of low, all over low, squared. Now, be very careful with this. You'll notice that big old negative minus sign in the middle. I'm going to turn it to a plus. And how do I do that? I'm going to distribute to one of the two factors. So now this is a negative 4, not a positive 4. Why do I do that? It's so that you don't forget to distribute the negative. So I'm going to get 4x times 3, which is 12x, 2 times 3, which is plus 6, 3 times negative 4, which is negative 12x, 3x times, and then negative 1 times negative 4, which would be positive 4, all over 4x plus 2, whole thing squared. Simplify, I get my 12x's will cancel, and I get 10 divided by 4x plus 2, whole thing squared. All right, there's the next one. Letter C. So C, I'm going to rewrite the function before I get started. I get negative 4 tangent of x to the 4th power plus cosine of x. So first part, this is the chain right here. And so h prime of x. Let's leave our constant multiple still sitting there. And I'm going to put the derivative of the chain rule. So the chain rule is really only having to deal with this piece. So what does that look like? Derivative of the out, leave my inside, times the derivative of the inside. So I'll do in 3 colors. Derivative of the outside would be bring the power down up to the 3rd power. So that's just b out. So that's this piece here. Leaving the inside the same, we'll do that in pink. All right, the inside was tangent of x, still the same. And then the in, we'll do in blue. That would be the inside's derivative would be secant squared x. So remember, the inside is just the tangent of x is the inside function. Now, there is more to the problem. Plus, the derivative of cosine would be negative sine of x. Now I just got to simplify this guy. I get negative 16 tangent cubed of x secant squared of x minus sine of x. Hopefully I'm not making any mistakes. Letter D. I'm going to rewrite the function first. 1/3 x to the 6th minus 4x to the 5th minus 3x to the 1/2 plus 6x to the negative 1/2 and then minus pi. So I'm going to take the derivative of every little piece. So constant multiple says bring down the constant multiple, take the derivative of the function next to it, 6x to the 5th minus constant multiple, multiplied by 5x to the 4th minus 3 times 1/2 x to the negative 1/2 plus 6 times negative 1/2 to the x to the negative 3/2, and the derivative of a constant number like pi is just 0. So there's my derivative. 1/3 times 6 is 2. X to the 5th minus 20 x to the 4th minus 3/2 x to the negative 1/2 plus 3, minus 3, sorry, x to the negative 3/2. So the ones with the negative powers, this guy and this guy, we're going to rewrite so it doesn't have the negative power. So a lot of times when you look at the answers, sometimes they'll let you leave negative. That would be the answer I have already. If they say no negative powers, then I would have to rewrite this to say that the 3 stays in the numerator, the 2 comes down to the denominator, and then we have the root of x. The last term, the 3 stays in the numerator, the x comes down to the denominator. So hopefully without any mistakes, that should be the answer. Letter E, f primed of x is equal to, well, this one's going to be a big pain. So not only is there a product rule, there's 2 chains. So before I get started in finding the derivative, you should be able to see this is the first function, this is the second function, and I'm going to find the d of the first function. Derivative of the outside, leave the inside the same, multiply by the derivative of the inside. Second function, derivative of the outside, leave the inside the same, multiply by the derivative of the inside. Alright, so I have everything I need. I'm just going to physically do my derivative now. So, leave the first function exactly the same as it was, multiply by the derivative of the second, so that's that big purple, for cotangent of x to the 3rd power negative cosecant squared of x, plus, let's do this in this color, plus, leave the second function by itself, but multiply by the derivative of the first function. There's everything partnered up, paired up, looks nice. Now I'm just going to simplify as much as possible. So I have this 4 and this negative. I'm going to bring that out front. Sine of 3x, cotangent is cubed, and then cosecant is squared. I have the 3 cotangents to the 4th power and cosine of 3x, and then I'm going to take out the GCF. So it looks like cotangent, there's 3 of them that I can take out. So cotangent cubed of x, that's my GCF. And then now, what's left over would be negative 4 sine of 3x cosecant squared of x plus 3 cotangent of x cosine of 3x. Alright, letter E. Letter F. I'm going to rewrite the function. To the 1/2. And this is going to be a double chain rule. This is my outside function. This whole thing is my inside function. Let's do f primed of x is equal to derivative of the out. That's just in red. Leave the inside exactly the same as it was. Multiply by, and we'll do pink. This whole thing should end up being dn. Now, multiply by dn, problem is, it's another chain. How do I know that? Take a look at our inside, right here. This is the full inside. This is another outside, and this is another inside. That's how I knew that it was another chain rule. So derivative of the out, we'll do in this maroon color. I'm going to leave the inside exactly the same in orange. Multiply by, in purple, the derivative of the inside. Well, the inside's derivative would be 20x to the 3rd power. Now that I have everything I need, I did this differently in class, but I will show you that there's one cosecant to the negative 1/2 power and a cosecant to a positive 1 power. Add those powers together, you're going to actually get that cosecant is now to the 1/2 power of 5x to the 4th. Now, things I have to fix. You see the 1/2 here in yellow and the 20x cubed. We're going to pull those to the front and we actually get, and sorry, even this negative. Get all those in the front, and we're going to have in orange negative 10x cubed, And so the only thing I have left to write in is the cotangent of 5x to the 4th. And that should be the answer for letter F. Bottom of the page, so it says, do not use the difference quotient for number 12a. Normal line is exactly the same as a tangent line. First of all, you need the entire point, x and y. Secondly, we need the slope, which won't be the same as the tangent slope. The tangent slope is f prime of a. You're going to do the reciprocal, which is 1 over, and the opposite, put a negative. And then you can use the y minus y1 equals m times x minus x1. All right, so I'm going to do the derivative first. Well, actually, let's do f of 1 first. So f of 1 would be 1 minus 1 over 4 minus 1, 0 over 3. So f of 1 is 0. Next thing I'm going to need the derivative at 1. So derivative of the high is 1, derivative of the low is negative 1. So low, d of high minus high, d of low, all over the low function squared. Now, same thing here. I'm going to add this, so change it to a plus. I'm going to change one of the two factors. You can change both of these into negative and positive, or change only that one. So we get 4 minus x in the front. Then we get x times 1, and we get negative 1 times 1. And then all over 4 minus x whole thing squared. We get that the x's cancel, and I get 3 over 4 minus x whole thing squared. I'm going to find the derivative at 1, which would mean I get 3 over 4 minus 1 whole thing squared. 3 over 9 is 1/3. Normal would be opposite reciprocal, so negative 3. Therefore, y minus 0 is equal to negative 3 times x minus 1. So really, we get y equals negative 3 times x minus 1 if I did not make any mistakes. All right, letter B. Find the x value where the tangent would be perpendicular. So tangent tells me I'm going to find f prime of x, which we already did. 3 over 4 minus x whole thing squared. Perpendicular would be opposite reciprocal slope. But we want to do it of this line here, so I got to find the slope of the line. How do I find the slope of the line? Easiest way, get y all by itself. Okay, 27. Y is equal to negative 1 over 27, x plus 5 over 27. The slope is negative 1 over 27, but I want the opposite reciprocal slope. So I would get positive 27. I'm going to bring that over, bring this over, and get that the derivative is equal to the opposite reciprocal of the slope of that line. So I'm going to multiply both sides by the 4 minus x squared. Some of you felt like this was magic in class today. Then I'm going to divide by the 27. And yes, you can cross multiply instead. From there, I'm going to take the plus or minus square root of 1/9 is equal to 4 minus x. I'm going to move the x to the left side, move the plus or minus to the right side. And then if your answer is not allowed to have that root, it would be 4 plus or minus 1/3. That's the root of 1/9. All right, so that would be where the function has a tangent line perpendicular to the other line that was given. Number 12, show that there are no horizontal tangents. Well, horizontal tangents tells me take the derivative, make it equal to 0, and solve. So what does that mean for us? It means that the derivative, which was 3 over 4 minus x whole thing squared, equals 0. I'll multiply by the denominator, and I get 3 is equal to 0, because 0 times anything. That can't happen, so there are no horizontal tangents. So those of you that weren't there at lunch, I did a review of some graphing, and that will be video number 4.